Alright, hi everyone. Today we are going to be looking at vectors, and before we start the class, these are what we should be gearing our mind up to. So by the end of this lesson, you should be able to state the difference between vectors and scalars, perform simple operations on the vectors, determine the sum and difference of two vectors, solve some simple problems on vectors. So let us look at the difference between scalars and vectors. Physical quantities are generally classified into two. We have the scalars and the vectors, or scalar quantities and the vectors. So your scalar quantities are quantities which you can describe in terms of their magnitude only. You can only measure their size or their magnitude. So such physical quantities are referred to as scalar quantities. Now, on the other hand, quantities which can be described in terms of their magnitude and as well as direction are referred to as vector quantities. So examples of scalar quantities are, but not limited to this, length, area, volume, mass, energy, distance, speed, density, and so on and so forth. So examples of vector quantities are displacement, velocity, acceleration, force, momentum, and so on and so forth. Now, if we take the motion of an object, for instance, let's say a boy who is walking, and the boy walks, let's say 25, or let's say 3 meters or 3 kilometers eastward. A boy walks 3 kilometers eastward, and then he walks 4 kilometers, let's say southwards. Then the total distance covered by the boy, because the distance is a scalar quantity, the total distance covered by the boy will be this. Let's say he moves from a point A, this is north, and this is usually east, this is west, and this is south. So if he starts from point A and moves 3 kilometers east, and then he heads down southward from this point on 4 kilometers, then his total distance moved is 3 kilometers plus 4 kilometers. So the distance moved by the boy, or covered by the boy, is equals to 7 kilometers. But displacement as a vector quantity, you have to put into consideration. Now, when an object is displaced, it means that you look at his final position from his original position. For example, this is where the boy started from. Okay, let's call this B. He moved from point A to B, 3 kilometers eastward. Now you see that as I want to find the displacement of the boy from his starting point, I am putting into consideration the direction in which he is moving. Then 4 kilometers down south to point C. Then look at the point where the boy is now. His displacement is the shortest distance between his final destination from his starting point, which is a straight line joining both points. So this is going to be his displacement. So you can easily see that this forms a right angle triangle. So by applying Pythagoras theorem, his displacement D is going to be equal to the sum of the square root of the sum of the square of the sides AB and BC plus 4 squared. So D is going to give me 9 plus 16. D equals the square root of 25. So his displacement is 5 kilometers from his starting point. So this is 5 kilometers from his starting point. Now take note that you have to determine his angle or his direction from his starting point. So we have to determine the bearing. So by doing this, let me calculate the angle here. The angle here, alpha, is going to be giving us tan alpha all is equal to, or alpha equals to arctan opposite over adjacent. So its opposite is 4 divided by 3. And when you divide this is going to give us, so this is going to give us arctan 1.33, and this is approximately 53 degrees. So this angle is 53 degrees. So his bearing is going to be the angle from here to this point. So his bearing is actually 90 degrees plus 53 degrees. So that is going to definitely give us 143 degrees. So he has moved a total distance of, or displacement of 5 kilometers, 5 kilometers from his starting point at a bearing of 143 degrees. So that is his displacement. So you can see that there's a difference between the displacement and the distance covered. So this example gives the difference between a vector and a scalar. Free vectors. Free vectors are vectors which do not have any particular position associated with them. So you cannot determine or state their particular position. So these kind of vectors are referred to as free vectors. So let us look at vector notation. So vector notation means the way we write the vector. So in printed work, that is the work that are printed on computers, on hard copies, a vector is shown in heavy print, that is in bold. For example, you can see this. This represents a vector A. In written work, a vector is shown by a letter with a bar underneath it. For example, this, you can see that I have A and a bar underneath it. A vector can also be represented by a letter and an arrow head over it, above it, or below it. So these are different ways of representing vectors. The magnitude of a vector A, this is vector A, which is sometimes called the modulus, describes the size of that vector, and it is written as in this form. That is the vector A enclosed by 2 strokes. So that is the magnitude of a vector. It gives the size of that vector, and it is also known as the modulus, just like finding the absolute values of numbers. So this is the modulus, or the magnitude of the vector. It represents the magnitude of a vector A included in between 2 strokes. So we'll take a look at a zero vector. The zero vector is a vector with magnitude of 0. The 0 vector has no particular direction. It is represented by the symbol 0. The 0 vector is sometimes called a null vector. So a vector whose magnitude is 0 and whose direction is also 0 is called the null vector or the 0 vector. The unit vector. The unit vector in the direction of the vector a unit vector, just a unit, one. That's what is the meaning of unit. A unit vector in the direction of vector A is the vector. So unit vector is a vector which is in a direction of another vector. So a unit vector which is in the direction of vector A is represented by a cap. You can call this a cap or a hat. A cap, or you call it a hat. So that unit vector is given as a cap or a hat equals a vector A, in which the unit vector is in the same direction with, divided by the magnitude of vector A. So that is the unit vector. The unit vector is a vector in the direction of the given vector A, and that vector is such that the vector is equal to A divided by vector A divided by the magnitude of vector A. The negative vector. The negative vector of a vector A is the vector which has the same magnitude as that of A, but in opposite direction to A. The negative vector of A is written as minus A, negative A. So if I have two vectors, let's say I have vector A in this direction, and I have another vector in this direction, they are antiparallel to each other. So this vector is having equal magnitude with this, so this vector is minus A because they are in opposite direction. They basically have the same magnitude but moving or acting in opposite direction. So this is vector A. So the negative of vector A is a vector which is equal in magnitude to vector A, acting in the opposite direction, and it is denoted as minus A. Equality of vectors or equal vectors. Two vectors A and B are said to be equal if they have the same magnitude and are also in the same direction. Okay, let's look at this. I have a vector A in this direction, then I have another vector B in the same direction. They are equal in magnitude, and you can see that they are parallel to each other. You can see that this is parallel to this, and they have equal magnitude. Unlike negative vector, which have the same magnitude but are opposite in direction. This, we have two vectors having the same magnitude and they are also opposite in the same direction. So these two vectors A and B are said to be equal vectors. So we look at the addition of vectors. Now let's see, consider this triangle having sides A, B, C. So if we have this triangle A, B, C, Now, there are two ways that I can start from point A and get to point C. The two ways are, one, either I move directly from A to C, or I move from A to B and then to C. These are the two possible ways that I can get to that place. Now, the vector AC is the sum of, or is said to be the sum of AB and BC. So we can write this as AC is equal to AB plus BC. Now, how do we arrive at this? How do I arrive at this? I said that if I want to go from A to C, I can either go from A to C directly, or I can move from A to B and then from B to C. Now, if we represent AB as vector A, this line AB, and we represent BC as vector B, then I'm going to have this. This is A and this is B. So therefore, AC is going to be equal to A plus B. So this sum, A plus B, is going to be equal to this. So this is going to be A plus B rather. So AC is going to be equal to A plus B. Now, we can see this. So this is the sum or the addition of what? Vectors. What you simply do is envisage this as you are going from A to C. How do I get to C? I can move from A to C by moving directly from here to this point, or I can move from A to B, then from B to C. Now, if A and B represent the position vectors of AB and BC, then AC equals A plus B. Now, let's look at the triangle law of vector. Now, we have demonstrated the sum of vectors. Now, the law, which says that AC equals AB plus BC from our previous section, is known as the triangle law of vectors addition. And we said that AC is equal to A plus B. So this AC, which is equal to A plus B, this A plus B is known as the resultant of vectors A and vector B. So that is the resultants of vectors A and B. A plus B is the resultants of vector A and B. Now let me redraw that triangle again. We have something like this. So I have A, B, and C. This was A, B, A plus C. Now this addition, A plus B, is not the normal addition where you have 1 plus 1 equals 2. Because you have to put into consideration that these are vectors which have magnitude and direction. So when doing vector addition, we put into consideration their direction as well as their what? Magnitude. So these are just to represent some algebraic formulas that you are going to apply or to solve for this. So this is the vector A plus the vector A plus B is the resultant of A, vector A and vector what? B. Now let us look at subtraction of vectors. We are in the previous section, we looked at the addition of vectors. here we are looking at the subtraction of vectors. Now, from the definition of a negative vector, we can say that the addition or the subtraction of vectors or two vectors is simply the addition of the negative vector. Now, suppose I want to find the difference between two vectors AB and BC. So their difference is going to be AB minus BC. Now let's look at this. I can illustrate this by having this. So this is A, B, and this is C. So this is vector AB, and this is vector ABC. Now I wish to look for the difference between them. Now I can do this. I can draw a similar triangle on the other side, having this. So this is B. So let's call this D. Now, pardon with my diagram. This should be of the same length. This should be equal to this. So let's call this D. Now, from this diagram, you will agree with me that since this and this are equal and they're in opposite direction, this is BC and this is BD. It therefore means that BD is equal to the negative vector of what? BC. Vector BD. Now let's see if I start from point A. If I start from point A and I move downward like this, and I'm going to C, I'm going to move like this, A to B, B to C. So I'm moving towards this direction. Now if I want to move to point D through B, I move like this, A to B, B to D. So you see that they are in opposite direction, but the same distance. So BC or BD is the negative vector of what? BC. So what do I do? AB. So I wish to look for the difference between these two vectors. AB minus BC is actually the sum of AB plus the negative value, the negative vector big C. Now the negative vector BC, the negative vector BC is actually BD. So therefore AB minus BC is equal to BD, okay, AB minus BC is equal to AB plus minus BC equals what? BD. So I can represent this vector, let's say A, this is B, and this is going to be what? Minus B, because it is the negative vector of this. So by so doing, AB minus BC, now AB plus BD is actually, this is it, AB plus BD is actually AD, because my destination to D is either I pass through A, from A directly to D, or I pass through this to this. So the resultant of this vector AB plus BD is AD. So AB plus BD is equal to what? Vector AD. Now what does this entail? AB plus BC, AB plus BC is equal to vector A plus B, and AB plus BD is equal to vector A. Now B is negative of this, so we are going this way, minus B. So you can see that this is A plus B, and this is going to be what? A minus B. So this example literally explains the sum and difference of two vectors. So the sum of the vectors AB and BC is A plus B, and the difference of the vectors AB and BC is A minus what? B. So this explains the sum and differences of two what? Vectors. So we take a look at the parallelogram law of vector addition. The parallelogram law of vector addition states that the resultant of two vectors is represented by the diagonal of the parallelogram whose adjacent sides are the two vectors. Now this is a parallelogram. Let's call this P, Q, R, X. So in this parallelogram, if these adjacent sides represent vectors A and B, the diagonal drawn from these common points of the vector will represent the resultant of these two vectors. Now you know that the opposite sides of a parallelogram are equal, so I can say that this is A and this side is also B. So by the definition of the parallelogram law of vector, PQ plus PS is equal to A plus B. And also, these two sides, you take them as adjacent side, PQ plus QR is equal to A plus B. This is the parallelogram law of vectors. The parallelogram law of vector is also equivalent to the triangle law of vector addition. Okay, polygon law of vector addition. Now suppose I have more than two vectors where I cannot use the triangle law of vector addition or the parallelogram law of vector addition, then I have to look for a way to find the addition of the several vectors that are summed up together. Now let's assume I have a vector. I have vectors, let's say AB, BC, BC, CD, D, E. I have these vectors 1, 2, 3, 4, more than two vectors. Now I will wish to look for the resultant of these vectors. The resultant is definitely going to be this AE. That will be the resultant of those vectors. So how do we get the resultant? Now you will agree with me that if I draw a line through this, the resultant of these two vectors, AB and BC, is going to be AB plus BC. Remember that I want to get to point C from point A. I have two ways of going there. Either moving through this place, or I move through here to B, then from B to what? C. So the resultant of this AC is going to be AB plus BC. So it therefore means that AC is equal to AB plus BC. And again, I am already at point C, or if I want to move from point A to point D, it is either I move through point A directly to D, or I move through point A to C, from C to D. So the resultant of AC through C to CD is going to be AC plus CD. So it therefore means that AD is going to be equal to AC plus CD. Now recall that my AC is what? AB plus BC. So I have AD is equal to AC replaced by AB plus BC. So I have plus CD. So it therefore means that AD is actually AB plus BC plus CD. Now let's try DE. So to get to DE, it's going to be AD plus DE. AD plus DE. So it therefore means that AE is equal to AD plus DE. Now, AE is going to be equal to my AD is AB plus BC plus CD. So I have AB plus BC plus CD plus DE. So from here you can easily see that the resultant of more than two vectors is simply the addition of the vectors. AE is equals to AB plus BC plus CD plus DE. So this is known as the polygon law of vector addition. Now, we will quickly take some examples to test our knowledge of what we have learned so far. So let's quickly look at these work examples. So example 1, if ABC is a triangle, meaning that ABC are the vertices of a triangle, what is the sum of the vectors represented by BC, CA, and AB? So we wish to establish the resultant of the sum of the vectors BC plus CA plus AB. Now we can illustrate this by drawing a triangle. Oh, let's have this. A, B, and C. Now from vector law addition, you remember that AC is equal to AB plus BC. Vectors. Now if you look at this, you realize that here I have BC, positive, positive. I have CA. CA is the negative vector of AC. So CA is actually equal to minus AC. So I have AB positive, AB positive. So here what we're going to do is to replace CA with negative AC. So this sum becomes BC plus minus minus AC plus AB. So we are going to have BC minus AC is AB plus BC plus AB. So this is going to give us BC minus times plus is minus. So BC minus BC. This cancels out this. Then I have minus AB plus AB. So this also cancels out this. So the resultant of the sum of this vector is equal to what? 0. Example 2. If the vectors AB are represented by the sides AB, AC of a triangle ABC, what vectors are represented by 1. BC, 2. CB, 3. AD, where D is the midpoint of BC. I would like to draw BC on the base of as the base of my triangle. So let's do this. I'm going to have this. So let me use this to represent BC, and this is going to be A. So I'll have AD, where D is the midpoint. So this is D. So definitely this is equal to this because D is the midpoint of BC. And vector AB is represented by A, and AC is represented by B. So we can now find the vector representation of BC. So what we simply do is this. I am going to BC. There are two ways I can do it. I either pass from B directly to C, or I start from B, move to A, then A to what? C. So the resultant of BC is going to be equal to BA, because I'm starting from point A to B. BA plus AC. Quite very simple. Just look at it, and assuming you are moving from one point to another, and look at the direction in which you head by using the letters. So BA plus BC. So we can now represent BC with letters A and B. So this is going to give us, remember that vector A represents AB, not BA. So BA is going to be a negative vector of what? Vector A. So BA is minus A plus AC is vector B. So we can say that BC is equal to B minus A. 2, that answers 1. 2, we are to look for CB. This is BC. CB is the reverse direction. So it means that CB is negative of vector what? B is negative vector of what? BC. So I have CB is negative BC. So that then this gives us minus B minus A, which is equal to minus B plus A, which is A minus B. So CB is A minus B. The next thing they ask us to look for is AD, where AD is the midpoint of what? BC. Now this is what I want to do. Again, I am at point A, I am going to D. How do I get to D? I start from point A, then move to what? D directly, or I start from point A, move to B, then from B to what? D. But BD, so it means that AD rather, is equal to AB plus BD. Now let's look at this. This BC is in this direction, BD is in this direction, and D is the midpoint of BC. So BD is equal to half of what? BC. But BD is half BC. I think I can find a way to squeeze this into this point. So let me squeeze this into this. So therefore, AD is going to be equal to AB. AB is A plus BD, which is half BC, half, and my BC is equal to B minus A. B minus A. So this is going to be equal to A, the LCM of this and this is something like over 1, A over 1 plus half. The LCM of this and this is 2. 2 divided by 1 is 1 times A, I have A, plus, 2 divided by 1 is 2, 2 times A is 2A, plus 2 divided by 2 is 1, times this, I have B minus A. So when I work this out, 2A minus A is A, then I have plus B divided by 2. So that will give us half A plus B. So these are the vectors that represent BC, CB, AD. BC is represented by B minus A, CD is represented by A minus B, and AD is represented by half A plus B. So let's look at the commutative law of vector addition. So we will look at this using this example. Show that if A and B are two vectors, then A plus B equals B plus A. Remember that the parallelogram law of vectors states that we can represent two vectors by two adjacent sides of a parallelogram. So if I have this, so let's call this A, B, C, and D. So this is A, B. Now the opposite sides of the parallelogram are equal. So this is B and this is A. So the resultant is usually here, drawn from their common point, the diagonal. So we can state that AC is equal to AB plus BC, which is equal to A plus B. Again, if you look at triangle ADC or ACD, you will agree that AC also is equal to B is equal to AD plus DC. So that will give us AD is what? B plus DC is what? A. So from here you can see that therefore A plus B is equal to B plus A. This is known as the commutative law of vector addition. So let's look at the associative law of vector addition. Example 4. If A, B, and C are three vectors, show that A plus B plus C is equal to A plus B, A plus B plus C. Now let's look at this. Let AB equals A and BC equals B, then CD equals C. So what this means is that I am representing these three vectors with sides AB, BC, and CD. Now, by the polygon law of vector addition, I'm going to have this AB, BC, and CD. Knowing fully well that, so this is going to be A, this is B, and this is C. So that's why I'm representing AB with A, BC with B, and CD with what? C. So the resultant of this vector AC I want to start from point A, I am going to point C, so I can pass through B and then to C. So that will give me A plus B. So this is A plus B. Now the resultant AD, okay, the resultant AD is going to be AD is going to be AC plus CD. AC plus CD, and AC is A plus B, CD plus CD, C. Again, I can start from point A and move to point B, and from B directly to point D. So in this case, I can have this. So the resultant BD, of these two vectors BC and CD is B plus C. So that means this vector here is B plus C. But like I said earlier, B plus C. like I said earlier, to get to D, I can move from A to B, then B to D. So if I move from A to B, AD is going to be equal to A plus AB, that's A, plus BD, which is what? B plus C. So if you compare this and this, you will find out that AD is equal to this and AD is equal to this. So therefore, we can say that A plus B plus C is equal to A plus B plus C. This is known as the associative law of vector addition. So next is multiplication of a vector. Multiplication of a vector by a scalar. So let's say let K be a scalar. Then Ka is defined as a vector which is parallel to vector A and whose magnitude is equal to K times the magnitude of what? A. Let's say for example I have a vector A. Then I have another vector. I am multiplying vector A by K. The vector Ka increases or reduces depending on what the value of K is. Now if PQ, okay, let's say this is AB and this is PQ. So if PQ, if the magnitude of PQ is equal to 3 times, that I'm saying that K is, a scalar K is 3 times the magnitude of AB, then vector AB is equal to K times A, or rather 3 times A, which is 3 times vector AB. Okay, so let's test our ability with more examples. Okay, next, example 5. A, B, C, and D are the vertices of a quadrilateral such that P and Q are the midpoints of side BC and AD respectively. Show that PQ equals half BA plus CD. So what do? Let us quickly draw the quadrilateral with vertices A, B, C, and D. So let's see. So this is A, B, C, and D. Now we are told that P and Q are the midpoints of side BC. So P is the midpoint of BC and Q is the midpoint of, okay, Q is the midpoint of side AD. So this is side AD, Q. So let's find the line joining them. This is the line joining them. So we have to show that this line PQ is going to have BA plus CD. So we can do this. Now what do? We can start from P. I want to start from P and move to Q. How do I do that? I move from P to Q directly, or I start from point Q, P rather, move to point B, from point B to A, and A to Q. So I'm going to have this. PQ is equal to PB plus PA plus AQ. Again, also, I want to move from P to Q. I can move directly, or I move to C, from C to D, D to Q. So it therefore means that PQ again is equal to PC plus CD plus DQ. Now, if I add P plus P together, PQ rather plus PQ, it is going to give me PB plus BA plus AQ plus PC plus CD plus DQ. Now let's look at this diagram. On looking at this diagram, we can see that BP and PC are equal but opposite. So the sum of PB and PC are equal but opposite. So the sum of PB and PQ will actually cancel out each other. Again, QA and QD are opposite in what direction? So we can look at this BP and PC. So let's see. Let's collect the terms that can cancel out each other. So I have PB. So when I add this and this together, I have 2PQ, P plus Q. Then I have PB is equals to PB plus PC, PB plus PC. So I have this PC plus AQ plus DQ plus, we are left with, I'm going with PC, okay, I'm going with PB, PC, so these two are off. I'm going with AQ and DQ, so we are left with BA plus what? CD. BA, so we are left with BA plus CD. Now you can see that from here, PB is equal in magnitude to PC, but opposite in direction, so they will cancel out each other. Again, AQ is in this direction, and DQ is equal in magnitude, but opposite in direction.